Hi, we are just displaying what we have done so far for 295A in our project Smart Industrial Equipment Maintenance using IoT and Predictive Analytics. First, I'll walk through the presentation, what we have done so far, and we'll give the demo of the implementation of vertical slice and few more components. So, the introduction of the project is that this time there is so much of mobile devices all over that we need something to take care of the data that is being produced by them. We need tools to analyze that and present those data in a very good form. We need new infrastructure and methods to analyze the stream of data. So this is where the big data is going on, and we need a good analytics tools to do so. The background of the project is based on Internet of Things, which is the network of physical objects that contains embedded technology to communicate and sense or interact with the internal states or the external environment. Also, we need analytics, which is the key to get the maximization of the assets productivity and process efficiency. We also need good tools to the visualization of the data. For the analytics that we have done, we need to show the analytics in a good visualized form. The goal of the project is that they are industrial organizations that don't get the proper insights regarding the failure of their components of their machinery or any other part, because they can't predict when their component is going to fail. The reason behind that is that as of now they only have the historic data to take care of those information, but they don't have any good tools to find out the way they can prevent any machine from breaking down. So we are building a tool which will have a dashboard consisting of real-time analytics on application data and predictive analytics to anticipate unfortunate situations using the real-time data. The real-time monitoring and predictive analytics will help organizations making smarter decisions on the fly. It will help enforcing potential failures, measuring performance, reducing downtime, optimizing schedule, and reducing maintenance costs for the organization. The whole project will be based on IoT framework and data analytics using real-time and predictive analytics. So just like I just discussed, the goal of our projects are reducing failure, maximize performance, optimize assets availability and life, lower risk exposure, decrease loss of service, optimize labor and operation cost, and few more. The features of our project is that it has real-time capabilities, big data processing system, predictive analytics. It gives good business intelligence to what we are doing right now with the system. Rule engines, recommendation system. It will help in creating decision on what kind of values you need to put into rule engine. It's open architecture, can be fit in various places in the industry across various platforms, and it's a very scalable system. This is our architecture. The architecture is, we have a producer, which is the sensors. It will send the data to the Kafka messaging service, which will send to the Strong, which will be taking care of all the real-time processing and dumping those data stream into our database. As well as we are using elastic cache, so that we don't lose any data and we can make a decision on the fly. Our backbone server is based on Node.js, and the client is based on D3.js, AMP charts, high charts, HTML, CSS, and various other front-end technologies. So for the implementation, our four main components are sensors, IBM IoT Cloud, where we will be hosting our data for the sensors, an app server which will be developed on Node.js, and a dashboard using HTML5, CSS, AMP charts, and D3.js. So the server-side implementation will be as follows. There will be two backend server processes. One will be used for analyzing the stream and triggering the action. One will be used to pull and push the data into database. We'll also have a rule engine which will be able to tell that what is the appropriate value to be set. So if something goes above the value or below the value, whatever the criteria the rule engine is, the action will be triggered. Recommendation based on historic data. For database, we are using MongoDB and Redis cache. For version control, GitHub. For client-side implementation, we are using dashboard showing the health status of the machinery, line charts, which will be the real time. We'll have funnel chart, bar charts, and various other statistic charts for the same. Progress so far, we have done our design, we have completed our system setup, we have implemented the whole vertical slice, we have also implemented our sensors to IBM Cloud, database design, dashboard design, statistics using visualization of tools, rule engine framework, and for methodology we have used Agile for the project management. This is the progress that I just walked through with the demo, and these are the features of our application, that it will avert and plan downtime, superior asset optimization, smarter decision on the fly recommendation system, parallel processing, cost saving. So now I'll just walk you to the same. So I just plugged in the sensor, and our TI Texas Instrument sensor that what we are using will be resume emitting the data points to the server. And here, like you can see, this data point is for ambient temperature. We can change to IR temperature, and this will give the current temperature right now at this moment where the sensor is right now. So if I hold the sensor right now in hand, the data will fluctuate, like you can see. So it's all real time. So we will be using this IBM Cloud for hosting our sensors data, and as of now we have collected the data for last 24 hours, and we have plugged that into the MongoDB, which we are using for our historical data analytics. So apart from that, there are various other streams of data that can be used, just like humidity is one of those. So this is the humidity point as of now. So now I'll just walk you through our application. So this is our login page. So this is our dashboard. This is how our dashboard will look. Here we have the random data, live data that's coming from the sensors. Apart from that, we have all the charts based on whatever data points we are capturing. As of now, we have just captured temperature charts and humidity charts. So as of now, I'll just display how temperature charts are. This is the 24 hours of data, last 24 hours of data for the temperature charts that has been collected from sensors. Apart from that, we have two more charts as of now. One chart is showing the aggregate temperature for these 6 hours of duration, like 12 a.m. to 6 a.m. the average temperature of 45 and 55 for 6 a.m. to 12 p.m. respectively, and so on. This one chart is used for displaying that how much times the data points recorded value between 70 to 80 or 117 to 6 in 60 to 70 and all that. Apart from that, we have similar time cost chart for humidity data also that we have collected for last 24 hours. When this application will be ready for production, what will happen is that even if we have a lot of data for every day, we'll just show the charts for last 24 hours. Apart from that, we have made a rule engine framework. This framework is used to test if the rule engines are working or not. As of now, we have just created a very simple framework to test a rule. So I have created a new rule saying temperature greater than 70, and you can do any of the action. So let's say I say send email, or let's say I say shut down the system. So if I do add rule, and I can do the test rule, so it will go and check into the database as of now that any of the values of temperature in last 24 hours greater than 70. If yes, then shut down the system. But in real time, when we have the system ready, it will be monitoring the real time data stream, and anytime any of the data points hit this criteria, this action will be triggered. So if I do a test rule as of now, it will say me shut down the system, and that's what the action was. So that's the complete thing that we have done as of now for 295A, and rest will be continuing further for the same in 295B. Thanks.